In the previous video, you have learned the meaning of modulus and argument of a complex number and how to find them. Now, before we proceed on to the next example, let us understand some very important note about modulus and argument. It is important to note that the modulus is always positive since it refers to the distance of the complex number z, the point representing complex number z from the origin. This distance r is always positive. For note number 3 is extremely important to understand what it means by the modulus of z1 minus z2 or z2 minus z1. It is the distance between the two complex numbers. For example, if we see modulus of z minus I, it means if I know z is a point here, and this particular point here on the positive imaginary axis, it represents I, then this distance that of the distance between these 2 points is represented by this notation. Understanding this notation is extremely important when it comes to the later section on loci. We have examined and understood that x is r cos theta, that is the real part of the complex number, and y equals to r sin theta. Argument z is measured in radians. This has been mentioned in the previous video. Now for point number 6, it means the position of p is unaffected by adding an integral multiple of 2 pi to theta, meaning that when we want to describe the argument of a complex number, it need not be unique. What do we mean? So, for example, if we look at a point on the imaginary axis, let's say the complex number I is represented by the point 1 on the imaginary axis. Now, it has an argument of pi over 2. But if we want to measure the angle from the positive real axis in this way, by going one complete round and reaching the line from 0 to 1 again, we find that we will have a full round of 2 pi plus pi over 2. That will be 5 pi over 2, and that is exactly the second one. On the other hand, we will have from the positive real axis to reach the same line that represents the same vector that represents the complex number I, we have this angle that I marked out in green, and that will be negative 3 pi over 2, negative 270 degree. It's negative because it's in a clockwise direction. So we see that we have yet a third way to represent the complex number and to represent the argument of the complex number. However, we usually choose the value of theta in this particular range. known as the principal range. Understanding this point 6 is important when we are solving complicated problems later on. Now let's move on to example 13. In example 13a, we are asked to find the argument of z equals to 1 minus I. To mark down 1 minus I on the Argand diagram, I will move 1 unit to the right, and I'll need to move 1 unit down because of the minus I. From here, to find the argument, I know that I will need to find the angle theta. When measure this way down, that's the argument. But then, we need to find the basic angle first. Now, the basic angle is the size of this angle. Now, there's a distinction between alpha and theta here. Alpha is the positive basic angle, but theta is a negative angle because it is the argument of the complex number and it is measured downwards, so theta is negative. First, we have to find alpha. From the diagram, we know that tangent alpha will be equals to opposite over adjacent, which is 1. So therefore, alpha will be pi over 4. Now, theta is negative, and the size of theta is the same as alpha. So theta equals to negative alpha, so theta is negative pi over 4. Look at part B. Now in part B, we are asked to find the argument of z equals to negative 1 plus I. So we again locate where z is, we move 1 unit to the left, and we move 1 unit up. So this length is 1, and this length is 1. We know that to get the argument, we are referring to this angle that we measure from the positive real axis to the vector line that represents a complex number. But then again, we will always need to find out the size of the acute angle here first. Let's call the basic angle alpha. To find tangent alpha, we know it is opposite over adjacent, so that gives us 1. So alpha is inverse tangent of 1, and that is pi over 4. That means that is this portion over here. Now we know that we have to find theta, the argument. From the diagram, you will see that theta is equals to pi minus alpha, so is pi minus inverse tangent of 1. So is pi minus pi over 4, that gives us 3 pi over 4. In C, to find the argument of negative 1 minus root 3i, we again first mark down the complex number on the Argand diagram. So negative 1 means we move 1 unit to the left, and we move root 3 unit downwards. So let's first find the basic angle alpha. We know tangent alpha is equals to root 3 over 1. Notice that I won't include the negative sign for negative root 3 and negative 1 here, because basic angle is always positive. I will always ignore the negative sign when I'm trying to find basic angle. So from here, alpha will be inverse tangent of root 3. That gives me 60 degrees, which is pi over 3. And this is exactly this part. Now next, for me to calculate the argument, I know that I have to start measuring from the positive real axis until I reach the line that marks the complex number. So it's this angle here. From the diagram, I know that the argument will be a negative angle because it is measured downwards. So I'll put a negative sign there. Next, I'll write down the size of the angle. We can clearly see that the size of the angle is 180 degrees minus pi over 3, where pi over 3 is alpha. So upon simplification, we get negative of 2 pi over 3. D. In D, we are asked to find the argument of 2 plus 5i. So again, we mark down the complex number in an Argand diagram. 2 in the positive real axis direction plus 5i means I will go upward by 5 units. In this case, the argument is given by this angle theta here, and it happens to correspond with the basic angle. So when we are calculating the basic angle alpha, tangent alpha will be opposite over adjacent, so it's 5 over 2, and alpha is inverse tangent of 5 over 2. That gives us 1.19, which is this portion. Now, since from the diagram we can see that theta and alpha are the same, so the argument z given by theta is equals to alpha is equals to 1.19 radians. Let's move to E. Now in part E, we are asked to find the argument of a real number, negative 3. Now we know that negative 3, to mark down negative 3, I move 3 units to the left from origin, so there's 3 units here. But then negative 3 is negative 3 plus 0i, so I will not move up or down. So the point P will represent the complex number negative 3. So from the diagram, we can see that the argument will be theta. So it is knowing that our argument must be between negative pi to pi, I must be careful to note that I should be measuring this way here. So I'll quote the argument as pi instead of quoting this way as negative pi, because we note that the principal argument doesn't include negative pi. That is why I will quote the argument as pi instead of negative pi. In 1F, there's a printing error here. It should be Z should be 4i. We are asked to calculate the argument of 4i. Now if we mark the complex number 4i on the Argand diagram, we know it's represented by 0 plus 4i is represented by 0. Since it's 0, I won't move left or right. Okay, but because of the plus 4i, I'll just move 4 units up from the origin. So from here, I can see that the argument is exactly this angle here, theta, and it's obvious that the argument will be pi over 2. Thank you for watching this video.